On this video, I'm going to show you how pointers work. But before we get to coding, let's take a look on how pointers work behind the scenes. So let's pretend this is memory, and these numbers here are memory addresses. In reality, the numbers are a lot larger, but for explanation purpose only, I'm going to use these simple numbers here. So when you first create a variable, let's say here on memory address number 2, you create a variable called age, and then you store the value 21 on this place. And then let's say you create another variable and you call it temperature, and then the temperature is going to be 100 degrees. And then let's say you create a pointer called x, and then x is going to point to age. So if x is a pointer and points to age, then the value of x is the address of 21. So x now will have 002. So because x is a pointer and it points to age, if I change the value of x, it may point to something else. But if I dereference the pointer x and change the value, then it will change this value here. So let's take a look on the code how that works. So let's create a variable called age equals 21, and we just did this equals 21. Now let's create a variable called temperature, and let's assign it 100 degrees, all integers, and that's what we did right here. Now let's create a pointer of type integer. Now notice that even though there's empty spaces here, I purposely skipped some places because you as a programmer, you do not decide which memory location your variables are going to be stored. The operating system does that. So this place here might be reserved for some other program, and your program is running only on memory location 2, 3, and 6. So again, you do not decide where this is going to be stored. The OS does it for you, which is great. So now let's create a pointer of integer. So int, and the way you declare a pointer is by asterisks. I'm gonna declare a variable x, which is what we did, and I'm gonna point it to the address of age. So I cannot just do that. I need the address of age, and the address is the ampersand. So right here, line 13, I create a variable x, and I'm pointing to age. When I do that, then the x now has the address, the memory location of variable age. So 2 here and 2 here. Let's print the address of the variable age. So if we print just x, and the value of x is the address of the variable age, so we're going to be printing 002. But remember, this is a simple address that I'm putting here only for explanation purpose. the real address is decided by the OS, and the number is a lot larger. So let's check out what the number is. So the address of the variable age is 0051, this number here. And every time I run this program, I'm going to have a different memory location for the same variable. Why? Because the memory is very dynamic. Many programs are using the memory, and every time a program needs memory, the OS allocates memory based on what the program needs. So it's constantly rolling. If you have one program only running, which is impossible, then you may get the same memory location. Your chances are it's not going to happen. So how do I print then the value 21, which is the value of the variable age? Well, to do that, you print what's called the reference. You dereference. And in order for you to dereference, all you need to do is put an asterisk right here, and now you dereference. When you do that, you actually print the value of age. So let's take a look. So first here I'm printing the memory location, which is line 15, and then 21 is being printed by line 16. Now, why do we like this? We like this because if we want to change the value of age through the pointer x, then we can do it. So let's do it. So x now equals 22. Well, what that happens is age now is 22 because we're changing the reference of x. So let's print now the reference, and only by curiosity, let's also print age. So the address 21, which we printed from line 16. Line 18, we change the value of age through the pointer, and then 19 we print 22, and 20 we're printing age. But now age has been changed through the pointer. So this is all possible. Now let's move on to temperature now. And I'm just going to put a new line here. So now let's point x, which is the same variable, to the address of the temperature. When we do this, what we're doing is changing the pointer now to temperature, and then because we do that, the x now has 003, which is the memory location of temperature. And if we print the value of temperature, now we got 100. So notice here we were playing with age, but then now we pointed the pointer x to temperature, and now we're playing with temperature. And then the same thing, you can change the value of the temperature through the pointer, and then you can print the value again, and now it's 99. And you can also print the temperature, and it's going to be 99 as well. So let's take a look. So here we did the age, and then on the temperature we print it, and this comes from line 25. And then on line 26 we changed the value of temperature through the pointer, and then we can print the reference of the pointer, and also you can print temperature, and you can see the value got changed. So the whole point here of pointers is that with one variable you can change around and find out, one, the address of a variable, or you can also change the value of the variable. The reason you can do that is because you know the address, you know the memory location of that variable.